All right, ladies and gentlemen, welcome to today's video. I'm working through some of the examples from the radicals and complex numbers review. Hopefully you find this helpful, and we'll try and review all the things that are important about radicals and complex numbers as we go through it. First thing up is number one. When you're adding radicals, how can you know if two terms can be combined? And the answer to that is going to be if, when simplified, you have to make sure you simplify them first. Simplified, they have the same radicand. And the radicand is the thing inside the radical. So something like root 3 and 5 root 3, you can add those together. But something like root 3 and then 5 root 5 would not be able to be added because these have the same thing in the radical and these don't have the same thing in the radical. So there you go. This is something that you need to know. It's a vocab term, the conjugate here. The conjugate of a set of binomials, typically complex numbers, but also when we have radicals here. Conjugates look like this. Oh, sorry. They're the same terms, but the middle operation is different, and that's all it is. Or you can see it as a minus root b and a plus root b. These are conjugate pairs. Conjugates always come in pairs. And so the conjugate for something like this is going to be 7 plus root 13. So it's the same thing. You just change the operation in the middle to subtract if it's add and add if it's subtract. Number 5 here. We're now getting into where you're just simplifying expressions, and that's really what these questions are that you're going to see on your final there. To simplify something like this, you're going to take the integers, the terms in front, and times those together. Negative 2 times negative 6 is positive 12. And then you're going to times those two things together, and that'll give you I squared. But something very important to remember is that I is the square root of negative 1, which means I squared is the square root of negative 1 squared, which means it's negative 1. And so this is going to turn into 12 times negative 1, which makes it 12. Sorry, negative 12. Duh. And there you go. Let's move on to this one. We're supposed to simplify this radical. Which to do simplify it, you're going to take a radical and start dividing it, just kind of do a factorization and figure out what numbers go into it. So think of a number that goes into 80. I don't know, I like 10. So 10 times 8, you can factor that out. Two numbers that make up 10 is 2 and 5. And then to get 8, you're looking at 2 and 4. And then to make 4 is 2 and 2. You can't factor 5 more. It's just 5 and 1. You can't factor 2 anymore. And so you're looking at these. And then to simplify it, you have to look at the end numbers here and find pairs. So here's a pair of 2's, and here's also a pair of 2's. And the pair of 2's are going to go in front of the radical, and whatever's left inside is going to be, well, left inside. And so in front here, you're going to have 2 times the square root of 5. So we got one pair of 2 going out, second pair of 2 going out. And then in front there, 2 times 2 is just 4. So it's 4 and then root 5. Voila, we have simplified our radical. Let's move on to another one. It's got a little bit more things. It already has something in front. But remember, when you pull something out, when you pull a pair out, you're just going to times this thing in front by that number. And then this really has 2 separate parts, and you should treat them as separate parts. So let's go ahead and do that. 108, that's 9 times 12. And 9 is 3 times 3, 12 is 3 times 4, and 4 is 2 times 2. So we got a pair of 2's, we got a pair of 3's, and then there's a 3 left over. So inside my radical, there's going to be a 3 still. And then there's going to be out front here 3 times 2 times the square root of, times that negative 6 that was out front. But we're still not done. We got to get this other part of our radical factored out. K to the third power is k times k squared, and k squared is k times k. Or you can think of it as 3 k's being multiplied together. But you can only pull out a pair of things at a time. So we're going to take out this pair of k's. This doesn't have another k to be paired up with, and so the pair of k's is going to come out. So it's going to be times in by k. Something I failed to mention earlier is that when you pull a pair out, only one of them goes out. You're effectively square rooting the pair of factors I got times together. So the square root of k squared is just k, which is why the k goes out front. Let me ignore that. So we do have this leftover k, and that's going to go back inside there. And so now we're just going to simplify this expression. We got k times 3 times 2 times negative 6, which is going to leave you a k. 3 times 2 is 6. 6 times negative 6 is negative 36. And then the 3k just stays inside there. So we're looking at an answer like this. Let's move on to another one. This is 2 sets of binomials. When to multiply those, you're going to take the first term and times by both of those. You'll distribute it in. And then you'll take your second term and multiply it by both of those. And then you'll simplify what you get after that. So negative 2 times negative 3 will give you a 6. And then we got negative 2 times negative I is going to give you a positive 2i. And then we got 6i times negative 3 gives you negative 18i. That's an 8. And then 6i times negative I gives you negative 6i squared. So we're going to be simplifying this down. A few things to remember. Remember that I squared is equal to negative 1. And so this part here is going to turn to negative 6 times negative 1. These combine because they have i's together, which you got 2i minus 18i, leaving you with a negative 16i. And then the 6 doesn't really have anything to combine with yet. This part here, negative 6 times negative 1, gives you positive 6. So these can combine. 6 plus 6 gives you 12. And then you got the negative 16i there, or subtract 16i there. All right, let's move on. We got 3 more examples if you'd like to keep following along. This one is the exact same idea. You got 2 binomials, but it's full of radicals. You're still going to take this first one and times by both of those, and then you'll take your second one and times by both of those and simplify what you get. So something to remember, if you have a radical times another radical, such as 3 root 2 times root 2, the parts inside the radicals times together, so you're going to get 3 square root of 4 there. So the things in front multiply together, and the things inside multiply together. So there's our first term. Our next one, you're looking at 3 root 2 times root 2 again. Oh, you know what? We could actually simplify this part to make it 2 root 2 and make this whole timesing thing a whole lot easier. I'm going to do that. Back up, back up, back up, back up. I'm going to do that. Erase. All right, here's what I'm going to do. So I'm going to simplify this right side here to make 2 root 2, right? If you have square root 2 plus square root 2, there's 2 square roots 2. And then we got these front side. We got 3 root 2 plus root 5. And now we're just going to distribute both of these to that term there. And so the stuff on the left side is going to turn into 3 root 2 times 2 root 2. The things in front times together to make 6. The things inside multiply together to make 4. So we get 6 root 4. And then we got root 5 times 2 root 2, which is going to give you 5 root 10. And so we're going to be adding these two guys together. The square root of 4 is 2, so this turns into 12. And then inside here, the 10 is just 5 times 2, and those aren't a pair, and they don't factor anymore. So the right part actually just stays the same. I don't know why you erase those. 5 root 10. And voila, now we have our answer. Except I totally did the 5 part wrong. It's not supposed to be 5 in front, sorry. It's supposed to be 2 in front, because I don't know how to read sometimes. Yeah, the number in front was 2, and that's 5 times the 2 there. So that's why it's root 10. So 2 root 10. Anyway, Moving on, we got 2 more examples, and these ones require multiplying by the conjugate. So in the denominator here, you may notice there's a radical. The only way you're going to get rid of this radical is by multiplying by the conjugate. If we were to try, don't actually write this down, if we were to try multiplying by root 3, you can times by that, and that will give you negative 5 root 3, and then plus 3, which is not a simplified thing. So we're trying to get the radical out of the bottom. And what we're going to do that is multiply the bottom and the top by the conjugate of this. Remember the conjugate thing I talked about near the beginning? That was the second question we went over. That's really handy because it gets rid of radicals in the denominator. So you do need to multiply top and bottom by the same thing. So you have root 2 times both of those, and then this one you have to do your double distribution to get it simplified. But let's work through it. Let's work through the top. Root 2 times negative 5 gives you negative 5 root 2. And then root 2 times negative root 3 gives you negative root 6. Alright, there's our top. And then on the bottom here, negative 5 times negative 5 is positive 25. Negative 5 times negative root 3 is positive 5 root 3. And then root 3 times negative 5 gives you minus 5 root 3. Sorry, my bottom's going to have to get bigger here. And then root 3 times negative root 3 gives you negative 3. These conveniently disappear. And that's one of the benefits of having it multiplying by the conjugate is your radicals are always going to disappear. So those are going to disappear. And I got 25 minus 3 on bottom, which gives you 22. And then on top, we got negative 5 root 2. And then subtract root 6. 6 is just 2 times 3, so there's no pair there to factor out. And so the top is done. And the bottom's done. So the whole problem's done. We got one more that we're going to do. It's number 24. Again, we are going to multiply by the conjugate to get rid of the I in bottom. Remember, I is the square root of negative 1. So it is a radical, and we're trying to get rid of the radical. And so we're going to multiply it by 2 minus 8i. I'm going to do that on bottom and top. 2 minus 8i on top. Remember, this whole thing is just timesing by 1, so it's not actually changing the value of our fraction. But yeah, let's go through here. 4i times 2 gives you 8i, and then 4i times negative 8i gives you negative 32i squared. And then on bottom here, we're going to have to do 2 times 2 is 4, 2 times negative 8i is negative 16i, 8i times 2 is positive 16i, and then 8i times negative 8i is negative 64i squared. Remember that I squared is negative 1, so this is going to turn into positive 32, so we got 8i plus 32 on top. And then on bottom here, these cancel because they're opposites, and you add them, you get 0. This part here is going to become positive 64, so the bottom is 4 plus 64, which will make the bottom now 68. And then on top here, we got 8i plus 32. These are all even, which means they're going to be divisible by 2 at least. And let's see if they're also divisible by 4. I think they are. Yeah, they look like they're. Yeah. They're all divisible by 4. So we're going to divide them all by 4, which will give me 2i. And then, hold on. I'm going to use a calculator. Calculators are great. And we got 8 and then 17. And voila, now we've simplified everything out. So there you go. A few examples from your assignment. Hopefully that helped you, how to do all of them. If you have more questions, post them on the discussion board and we'll try and answer them.